This is a story of how a remarkable figure died and revived and revenged. His family was killed by the terrorist. He himself also died when Tony Stark is trying to escape.
Stop.
But no, he is not your son. He is this guy with no name. Witnessed the death of his parents. He surrendered and joined the terrorists in order to stay alive. He is now the leader of a local terrorist group, but that was just his plan. And using his power as a local leader, he has been looking for the killer of his family for the past 20 years. But now, with a hole in the chest, he believed that he will never make his revenge. But that's only the beginning of the story.
Who
are you? Stay back. Stay back. I'll hurt you if you get any closer. No.
The first one is the constant suit, which can generate a vertical and constant current that follows a straight path. The current will induce a horizontal magnetic field, whose strength can be represented using Ampere's law. He can use this magnetic field to deflect incoming charged particles. The magnetic force experienced by the charged particle can be modeled by the Coulomb's law for magnetism, and then Newton's second law is going to be used to find acceleration of the particle later on. The second one is the constant spring boot, which is only on his right leg. The boot has a compressed spring at the bottom of it, and when the situation is of emergency, the spring will release and the resulting force will send the protagonist upward quickly. The protagonist can change the spring constant with his will. With the definition of gravity and spring potential energy, and the definition of kinetic energy, together with the law of conservation of energy, the necessary spring constant in different situations can be found. The static friction constant of the boot can also be changed by will, and the law of static friction will be used to calculate the necessary friction constant accordingly. The last modification is a spring fist. The fist has a spring connected to it, and the spring constant can be changed, again by will. By setting the constant to 0, the fist can be thrown out easily and attached to an object, and by increasing the constant again after that, the energy of the spring contraction can be converted to kinetic energy of the moving object. This can be modeled by the law of conservation of energy. And the fist can also change the friction constant of the moving object that it touched, to reduce the resistance that the object experiences, and this will make the final kinetic energy even greater. Then, the fist can also function as the capacitor. When the protagonist flattens his conducting hand and separates them, they collectively function as a capacitor, whose capacitance can be modeled by the graph and function on the right. He can manipulate the charged particles in his two hands to create a maximum of 1 coulomb of net charge on each hand with opposite signs. And this separation of charges creates a voltage which can be modeled by the function of the definition of cell capacitance of conductor.
I woke up in a hospital with very little memory of the events that happened earlier that day. Back where I came from, we had these people called the Avengers. They fought bad guys. So, armed with the power of this strange constant stone, I can finally fight criminals to avenge my parents. And after that, I got turned into the Doctor of Applied Non-Real Kinematics, the Master of Elementary Magnetism and Electricity, or DANK for short. Today, I just found the one that made this personal, the Bronze Lad. Stop right there. I know what you did.
You'll never stop me. I've created the ultimate weapon. This supersuit. Your springs won't have any effect on my incredible armor.
Alright, Marvis, help me out here. Any weaknesses?
Analysis completed. The main mobility module of the suit is powered by a 12.6-volt car battery, and a high voltage will override the battery and make the suit explode. But first, you have to find a way to apply 800,000 joules of energy to break open the suit, and then you can locate the circuit that is connected to the battery.
Alright, break that suit first. I'm going to need some really powerful force.
I've got something really powerful for you first. Electron beam, activate! What? Impossible! How did you do that?
Whoa, how did you do that one, Marvis?
The incoming projectiles all have the same mass, which is 9.11 times 10 to the negative 31 kilogram, and that's the mass of electrons. And they all have the same charges, which is about 1.6 times 10 to the negative 19 coulombs, and that's the charge of electrons. The approaching speed is found to be about 5% the speed of light, which is about 1.5 times 10 to the 7th meter per second, and that is the speed lightning is traveling in the air. The electrons are initially 15 meters away, and the speed is constant. Time t equals to 0 when the electron is launched, and they immediately accelerate to their constant terminal speed. We will need to find the appropriate magnitude of the current. We use letter I to represent the unknown constant current. Now, with the ability to create a horizontal magnetic field by running a vertical current, we can create a magnetic field that will make the incoming electrons experience a vertical force. The current will be from bottom to top. Since according to the right-hand rule, direction of the resulting magnetic force will be pointing downwards, and also because the electrons actually goes the opposite way, they will experience an upward force and be deflected. The electrons must move at 0.5 meters to not hit you. We can first set up the force that the incoming electrons are experiencing. And since the angle between the incoming electrons and the horizontal magnetic field is 90 degrees, the cross product can be ignored and the magnitude will simply be the dot product. And then we set up the Ampere's law's function to represent the magnetic field. And since the current follows a straight path and is constant, we can simplify the expression. And plugging in the expression of magnetic field in the expression of magnetic force, an expression of magnetic force with respect to distance that is left between the electron and u, which is represented by r, is established. Then, using the old guy's second law, I guess, F equals ma, the left side can be substituted as m times a. And then after rearranging, we can find an expression of acceleration of the electrons with respect to distance. The distance, with the electron traveling at a constant speed, can be also modded by the original distance minus the speed of the electron times time. Substituting this expression in the place of distance, we have our final expression of acceleration with respect with time. By first doing an indefinite integral, we can have a general expression for velocity of the electrons that are traveling upwards. And by plugging in the initial condition, v0 equals 0, the constant c can be found to be 0. We then do another integral with the newly developed function of speed, but this time, this is going to be a definite integral, with the lower bound of 0 second and the upper bound being the time it will take the electrons to travel the 15 meters. And since the speed is constant, the time can simply be distance over speed. And then, using the power of my calculation devices, an expression with an unknown current, which is represented by I here, can be generated. The expression is the distance that the electron will travel upward with the influence of the magnetic field. The distance must be at least 0.5 meters, and we can establish our last equation accordingly. And finally, solving this equation is going to give us a result of 4.270 amperes, which is about the current generated in an old plasma TV. So, I let your suit generate a current of 5 amperes to let you be absolutely safe. You're welcome.
I understood about half of those words. Anyway, I have an idea on how to get that force to him, and luckily, I got my degree in non-real kinematics. Alright, me, here's the plan. Who are you? I'm you, but in your head. Why do I sound slightly different? No idea. Anyway, here's the plan. Find something that's, I don't know, 1500 kilograms, then throw it at him from at least 20 meters with the spring constant, probably a steel wire. Then change the spring constant to exactly 0.02. That should be enough to get our 800,000 joules. How do you, well, I know that for sure. It's all simple non-real kinematics. first set up an equation for conservation of energy. It somehow still gets conserved. Don't ask me why. You'll be able to set up the spring formulas on one side with a gap of 2 meters so you don't hit yourself with a car, then set up the kinetic energy and friction on the other side. After that, plug in a spring constant of 4041.88 and the required energy is around 800,000 joules. Then solve for the friction constant. It's actually pretty easy.
Alright, me. So how do I make sure I don't hit myself with 800,000 joules of kinetic energy when it's reeled in?
Well, that brings us to another setup. Again, we use conservation of energy because it makes things simple for both us and the universe. Set up spring energy on one side and the kinetic energy for our 80 kilogram self will need to avoid it on the other side. After that, plug in the speed we'll need, it's about 24 meters per second, and solve for the spring constant we'll need to set. Apparently, we're going to need the compressive strength of residential concrete on those things to do it.
I think that car weighs enough. Come on, now! You may have broken my armor, but that means nothing! It's not like you produce 12.6 volts or anything like that! What is that?
That is a capacitor, my friend, and it will kill you. The two hands are conducting and are separated. They collectively function as a capacitor. We assume that the gap between the two hands is filled with nothing, so we do not need to modify the vacuum permittivity. The hand have the same surface area of 0.0473 square meters, which is the average area of an adult's hand. And the distance between them is about 0.1 meter. The expression of a capacitance can then be set up, and with values plugged in, the resulting capacitance can be calculated. Now we need to find the magnitude of charge we need on the two hands. The voltage generated by a charged capacitor can be expressed, and then we set up an equation with the target voltage of 12.6 volt, which is the voltage of the battery on the suit of bronze lead, which is also the voltage of a common car battery. Plugging in the capacitance and solving the equation will give us a value of 5.274 times 10 to the negative 11 coulombs, and that's our target, which is just about 3.3 billion electrons. Wow. Anyways, I'll rearrange about 1,000 coulomb of charge just because I can, and the resulting voltage will certainly be higher than 12.6, and bronze lead will certainly explode.
Awesome. Well then, bronze lad, I may not be the good or the bad, but I sure am the constant.
No!
At last, I've finally done it. I can finally rest.
Initiation of physical capacity. Without the